Good morning, my ECO 3311 students. Earlier on today, I recorded uh, the end, the portion of chapter 19 because there were only about 3 slides remaining on chapter 19. So I'm going to upload that video as well to go along with what I did yesterday. So make sure you're watching those videos and taking notes and just like you're in the classroom. So that was chapter 19. It was a chapter about the demand for money. So as I told you guys, uh, chapter 4, which we're going to be embarking on today, is going to be a chapter on interest rate, okay? The meaning of interest rate. So we're going to try to start talking about interest rate. Um, how do we calculate the interest rate on financial instruments? And we're going to talk about this in regard to 4 credit market instruments, which is going to be fixed payment loan, simple loan, coupon bonds, and discount bonds. But before I start, I have an important announcement that I want to make. Your midterm exam 1 was scheduled for this Friday. I scheduled for this Friday. But the way I'm looking at my clock, it looks like Friday is too tight for you guys, especially for the first midterm exam, which I always view as very important. So I'm trying to give you guys an extension on the exam. So instead of taking the exam this Friday, I'm going to extend the exam until Monday next week to give you guys a little bit of breathing room to study over the weekend, prepare for that first midterm. I'm going to send a detailed email again to remind you guys that the midterm exam 1, which was scheduled for this Friday, is going to be shifted to Monday next week. Okay, so let me begin here. I'm going to share my screen on the new chapter that I'm going to be talking about today, which is chapter 4. I will talk about it on the other side. So here's a chapter about the meaning of interest rates. So I have also posted a handout. It's a mathematical handout that I prepared for you guys. Because a lot of time we're going to be using time value of money, calculating present value, future value, the rate of return on a bond investment. And most of the time, students who are doing finance, you resort to using your financial calculator too soon. I'm an economist. I'm going to show you guys that even without the financial calculator, we can still use math and regular scientific calculator and get the same answer that the finance folks are going to get using the what? Using the financial calculator. For example, if I ask you to calculate the present value of a fixed payment loan, given the what? The face value, interest rate, number of years to maturity, you have 2 options. If you know you're comfortable using financial calculator, you can go and use a financial calculator. But if we even in a world without financial calculator, I'm gonna derive some formulas that you can use. You can easily program using a regular scientific calculator, and you're gonna arrive at the same answer. And the people who know how to use a financial calculator already, they should appreciate this because if you're only pressing on a financial calculator, sometimes you don't know what the kinds of calculations that are being done underneath that calculator. So you will appreciate the formula method that I'm going to be deriving from. These formulas are going to be the ones that got programmed underneath that financial calculator, that when you press present value, it gives you the value, the answer almost instantly. So anyway, let's kickstart. So that handout is already under the course modules. I'm going to go through it as part of this chapter at some point. But let me first introduce the chapter. So this is the meaning of interest rate, which is chapter 4. So before we can go onto with the study of money, banking, and financial market, we must understand exactly what the phrase interest rate means. In this chapter, we see that a concept known as a yield to maturity is the most accurate measure of interest rate. So in finance and or in economics, the word interest rate is going to be analogous to yield to maturity. It's the same thing. So the yield to maturity is the interest rate that equates the present value of a financial instrument like bonds to their future value. Okay. So we'll talk about it. So here's going to be the learning objectives for this chapter. And this chapter involves a lot of calculation. I want you guys to pay attention. I'm going to go as slow as I can possibly, cover this course. Go a little slower, make sure that everybody, when you watch this video, you should be able to do those calculations. I'm going to assign homework number 2, which will be based exactly on chapter 4. So to allow you to practice and get ready for the midterm exam. Plenty of questions are going to come from chapter 4 as well on the midterm exam 1. So make sure you understand this chapter very well. So the learning objectives are, we're going to calculate the present value of future cash flows, okay? And the yield to maturity on 4 types of credit market instruments, okay? And those 4 types of credit market instruments, I'm going to list them right here, right away. I mentioned it. They're going to be things like 1, simple loan. And then 2, we're going to call a fixed payment loan. And then we're going to talk about coupon bonds. And number 4 is discount bonds. So after I've covered this chapter, all of you should be able to know how to calculate the payment on a loan. If you go and take a loan, a car loan, for example, nobody should cheat you. You should know how to calculate what your monthly payment is going to be. You guys are going to be amazed to see the level of ignorance, that there's so many Americans out there who people take advantage of them on a day-to-day basis. They go and buy a house. They got to go buy a car. People are going to buy cars every day. And when they buy a car or buy, a house, they're taking on a loan. So they are always at the mercy of the financial professional who are giving them those loans. If they make any mistake, calculating what their fixed payment on a loan is supposed to be, then they are screwed. They're going to be victims of that. I don't want you to be a victim of that. Once you've taken this class is not about only passing the exam. There are some chapters, especially this chapter, that you want to learn something that you can actually apply it in real life. Okay, and you're going to be surprised. A couple of years ago, there was I told my students that when you go buy a car, shopping for a car is not like shopping at Walmart. Well, they allow you you have to go and negotiate for if it's a used car, you negotiate for the price. So it's $25,000. Maybe you're gonna put 5 down, and then you're gonna finance 20,000. You take a loan to finance $20,000, and then you're gonna write. So 20,000 will be the loan value or the present value of the loan, and then you guys negotiate on the interest rate. If you settle, let's say the interest rate is 5% on the loan APR, and then you're gonna be paying it off in 60 months, which is 5 years. 60 months is 5 years. And then the financial professional is going to do the calculation on their computer, on their calculator, and say, oh, your fixed payment is going to be like $350 a month. Please don't take that as a yes. I want you to learn how to calculate your own payment on a loan. You're allowed, yes, the dealership allows you to test drive a car without signing any documents yet, like signing on a loan yet. You can tell them, hey, can I test drive the car for 3 days? After you've already agreed on the terms, you know how much loan you're going to be taking. You know what the interest rate is. You know how many months you're going to be paying off this loan. You go home and do your own calculation. Most of the time, your numbers might be different from what they're telling you at the dealership. There's a girl who took my car, and I told them the exact same thing. And one time she was buying a car, she knew how to calculate our payment, and they were cheating her by $60 a month. And she went and yelled at them and said, I know how to calculate. Why are you guys doing this? Those kind of stuff. I'm not suggesting that the people at the dealership are crooks, but, I don't trust anybody. They could be, or if they are not trying to take advantage of you, they could make mistakes using that financial calculator. I don't want to be a victim of somebody's mistake. And that's the same platform I want you guys to have. You have to be knowledgeable about this concept of time value of money. It's going to help you save money when it comes to like picking on loans or even investment. When you start talking about, when you understand what a coupon bond is, now you start going to invest your own money, when you're investing in bonds, you know what you're getting into. So that's a whole, and then we're going to recognize the distinction among yield to maturity, current yield, rate of return, and rate of capital gain. We talked a lot about that. And then we shall interpret the distinction between real and nominal interest rates. Okay, so those are the learning objectives. So measuring interest rates. So the present value, let's start with the concept of present value. The present value hints on the notion that a dollar that is paid to you 1 year from now is less valuable than a dollar paid to you today. Okay, what do I mean by this? So let's say it's your birthday today, and your grandpa asks you that, hey, Johnny, should I give you $100 for your birthday today, or do you want me to give it to you next year? Tell your grandpa that give it to me today. Okay, if you're giving me next year, it better be $110. If the interest rate is 10%, because that means if your uncle gives you the money today, that $100 more that is given to you today is more valuable than the $100 that's going to get paid to you next year. Why? Because you're going to receive $100, put it in the bank. It's going to earn interest. After 1 year, it could be worth $110. Okay, so a dollar paid to you today is worth more than a dollar paid to you tomorrow. That is the whole concept of finance. So that's exactly what I'm saying here. If somebody pays you $1 today, you're gonna put that dollar, invest that dollar in the bank. So after 1 year, because you see, if you put $1 in the bank after 1 year, its value is gonna be 1 times 1 plus I, because it's gonna be 1 times 1. That's gonna be what you put in, which is $1 plus then $1 times the interest rate. If the interest rate is 10%, 10% is 0.1. So that's going to be 1 times 0.1. So you get $1.10 at the end of what? Period 1. Okay. So to understand the importance of this notion, consider the value of a $20 million lottery payout today versus a payment of $1 million per year for each of the next 20 years. Are these two values the same? We'll talk about that shortly, about if you win a jackpot at lottery, how much you actually get paid. Okay, so let's do a couple of whatever. So let's think about $100. If the interest rate is 10%, 10% is 0.1. So when I say I is 0.1, that's the same thing as saying I is 10%. It's 0.1 in decimal, but 10%. So in 1 year, if you deposit $100 in your bank account, after 1 year, is going to be, your money is going to grow to $100 times 1 plus the interest rate. Because if you multiply $100 times 1, that is what you put in. That's the principal you put in the bank on January 1, say 2025. And then when you multiply $100 times 0.1, that is going to be the interest rate portion that will have accrued on your $100. So at the end of year 1, you're going to end up with $110, which is what you put in 100 times 1 plus the interest portion, which is $10. And then if you, let's say on January 1, 2026, which is the second year, you roll this money back into that savings account, you don't withdraw it. So after that means towards the end of period 2026, you're going to roll $110, of which you have accumulated through year 1. That's going to pay you again 10%. So at the end of year 2, you're going to get $121. And then year 3 is going to be, you roll this through 2027. At the end of year 2027, you're going to get $133. Okay, so so we can write this formula in a much condensed form. Okay, so we're going to say, basically just going to say let me open a new slide here. Okay. So what we're saying is that if you invest $100 in your bank account today, after 1 year, your money is going to grow to what? 100 times 1 plus the interest rate, which is 0.1, 10%. You have to enter in decimal, which we found this to be $110. So after year 1, end of period 1, 2025, you're going to get $110 in the bank. If you don't withdraw the money, that means that money gets reinvested automatically. So after year 2, you're going to have throughout year 2, it's going to grow again to 110 times 1 plus 0.1. This is going to be equal to $121. So at the end of period 1, that's what your money total sum. And then after year 3, you're going to have $121 roll over. It's going to be times 1 plus 0.1. This is going to give you, you're going to end up with $133. So in general, as n gets large, we're just gonna say the future value of your money is linked to the present value using this formula multiplied by 1 plus I raised to the power n. That's one way of writing it. So this FV, okay, so my variables in this simple time value of money, FV stand for, FV is future value. Future value is also what we call cash flow. You can call this as or cash flows. Okay. PV is a present value, the value of your money today. And then I is a yield to maturity or interest rate. Yield to maturity, or you can just call it interest rate. And is a number of years to maturity. For example, if you invest money in your bank account, in a savings account, and leave that money in the bank for 20 years, so N would be 20. And then the interest rate is 10%. This is you put $100. So after 20 years, you can figure out how much your money is going to be, how money has grown in the bank. Okay, so this is a formula. This is a simple formula that we use a lot when we are trying to figure out the time value of money formula. Okay, so I'll go back here. So I want to insert a slide here. Okay, so we are basically saying the present value is given as so I'll start with future value. So future value equals to present value inside 1 plus I raised to the power n. That's one way of writing this formula. Or you can make PV the subject. If you divide both sides by 1 plus I to the power n, you can also write this formula as present value equals to future value divided by 1 plus I raised to the power n. So n of this formula can be used to figure out what the future value or present value. Okay. So when you put these things on a timeline, okay, it's kind of gonna look like so you see here I wrote it a little bit differently because remember cash flow, CF stands for cash flow, and cash flow is the same thing as future value. So that's the same thing. You can read this is the same thing as PV equals to, if you want to, some people might just write FV like we did earlier, 1 plus I to the power n. Because future value is the same thing as cash flow. And when you put it in a timeline, so the present value of $100 that get paid to you today means the time is 0. Today, this, time has not yet elapsed yet, it's 0. So n is 0. So in that formula, if you're getting the the present value is given as future value or cash flow over 1 plus I to the power n. Because the future value is given as $100. That's what you get paid today. But today, this they say was 0.1. Today is raised, n is 0. Any number to the power 0 is 1. You know that. So 1 plus 0.1 raised to the power 0 is going to be 1. So that means the present value of $100 that get paid to you today is actually $100. But the present value of $100 that get paid to you 1 year from today, you're going to have what? PV equals to future value. So $100 is going to get paid to you next year. Next year means 1 plus interest rate raised to the power 1. Okay. So if you can do the math here, if if interest rate is 10%, so that means the present value is going to be $100 divided by 1.1. 1.1 to the power 1 is 1.1. So $100 divided by 1.1, you get what? Let's check here. My calculator here. $100 divided by 1.1. So it's $90.91. See? That's what we say. The present value of $100 that gets paid to you in the distant future, like next year, is worth less than $100 because we have to discount the future. And then the one that gets paid to you in year 2 is even going to be a lot less. The more distance in the future, the smaller is the present value. So the present value is inversely related to the number of years to maturity. As n gets big, the present value of your money gets smaller. Okay. So I want us to talk about, we're going to talk about this low rate question for sure later on. But I want us to understand this present value in the context of a simple loan. Okay. So we are going to apply this to these 4 credit market instruments. There are 4 types of 4 main credit market instruments. Okay. First one is a simple loan. A simple loan is a loan which is too simplistic. Let's say you went to a bank and then you apply for a loan and you get approved on the spot, maybe just a $5,000 loan, $1,000 loan. Sometimes we call it signature loan. There's not a lot of complicated legal contracts involved in a simple loan because the banks know that even if you don't pay back $1,000, that does not put the bank in a lot of financial jeopardy. But if it comes to loans like mortgages or student loan or car loan, those are what we call fixed payment loan. They're a little bit more complicated. Okay. A simple loan is we call it signature loan or cashier loan. You get approved on this spot and the cashier dispenses the cash, give it to you on the spot, and maybe at the bank or put it in your bank account right away. So the simple loan, so for a simple loan, let's figure out. So for the simple loan, we're going to use the formula. Let's start talking about a simple loan. And we're going to do a couple of examples. Okay. So the formula that we just derived for present value, which we say present value equals to cash flow. Remember, cash flow is the same thing as future value divided by 1 plus I raised to the power n. This is a formula we're going to use for figuring out what future value or present value of a simple loan. So let's do one example here, clear up our understanding here. Okay, so let's say I'm going to do one or two examples. So we'll say example 1. I can say, suppose you pick as a loan from your bank equals to $1,000, which has to be paid back in full plus interest of 10%, interest of 10% per year in 5 years. So your loan matures in 5 years. That means after 5 years, you're fully paid. Then I ask you, calculate how much you will pay back in 5 years or after 5 years. So when this is very easy. Summarize, because that's why we call it a simple loan. So we have been told the interest rate is 10%, which is 0.1. And is 5. The loan has to be paid back in 5 years. And the present value of the loan, present value is so-called the loan value, is $1,000. So what we have been asked here is to calculate the future value, because that's how much you're supposed to pay back in the future in full amount. So you're just going to apply that formula. So the formula say that future value equals to present value inside 1 plus I raised to the power n. Or you can start writing present value, but since we're calculating future value, we want to make future value a subject. It's much easier to calculate that way. So future value in this case is going to be, because you substitute your known values. Present value is $1,000 here. In bracket, 1 plus 0.1 raised to the power 5. So you get your future value equals to $1,000 times 1.1 raised to the power 5. So if you do use your calculator, just a regular scientific calculator, so you get 1.1 raised to the power 5, enter, then multiply by $1,000. So that gets me, so you're going to be paying back $1,610.51, meaning that the interest on that loan has accrued by $610.51, because you borrowed $1,000, but that's how much you're going to end up paying in full amount, which include interest after 5 years. So as I see, it's very simple. Let's do another example. Let's do example 2. So in example 2, we could say, we can say, suppose you pick a loan of $2,000 from your bank, which has to be paid back in full amount of $3,200 in 5 years. And then I could say, what is the interest rate or yield to maturity on this loan? What is the interest rate or yield to maturity on this loan? So again, this is very easy. So what we're going to do, we're going to open our new slides and solve the problem. Very easy. So what you summarize what you know. We have been told that what? So the solution here, start from here. We know the interest rate is what we are solving for. The present value has been given. The value of the loan is $2,000. But you're paying back. That means future value of $3,200. What you pay back in what, 5 years. And is 5. Okay? So here, solution, you're gonna say, we know that future value equals to present value inside 1 plus I raised to the power n. Then we're going to substitute the known values. You're going to pay back the future value of $3,200. That's what the question says. Must equal to present value. You took out $2,000 from the bank. Inside 1 plus I. We're solving for that I raised to the power 5. Okay? So the first thing we're going to do, we divide both sides. An equation, what you're doing down on the left, you must do right. Divide both sides by $2,000. If you do that, the left-hand side becomes 3,200 over 2,000 must equal to $2,000 divided by $2,000 inside 1 plus I raised to the power n. So this cancel. So 32 divided by 20, what do I get? 32 divided by 20 here, you're going to get 1.6. So this is 1.6 must equal to 1 plus I raised to the power n is 5. You should have started to say this is 5. Okay, so now this is if you raise something to the power 5, we can get rid of that. Let me give you some little bit of example. Yes, you know, this side note here. You know how to solve this problem. If you have x raised to the power 3 equals to 5, and somebody asks you to solve for x, how do you go about it? You can raise both sides to the power 1/3. So the left-hand side can be written as 1 x to the power 3 raised to the power 1/3, because equation, what you have done on the left, you must do on the right. If you are raised to the power 1/3, the 3 cancel this. So you get x equals to 5 raised to the power 1/3. Then you can use your calculator to find it. That's a side note. It's going to be the same thing here. So when I say 1.6 equals to 1 plus I to the power 5, if I raise both sides of this equation to the power 1/5, then the left-hand side is going to be 1.6 raised to the power 1/5 must equal to 1 plus I raised to the power 5, but this is all going to be raised to the power 1/5. So the 1/5 is going to cancel the 5 there. So what you're going to left with, you're going to, let me open a new slide and finish that up. Okay. So you have 1.6 raised to the power 1/5 must equal to 1 plus I. Okay, then you're going to use your calculator here. All right, so that is 1.6 raised to the power, you introduce bracket, 1 divided by 5, close bracket. So the left-hand side is going to be 1.0986. If I round it to 4 decimal places, that's going to be equal to 1 plus I. Now to solve for interest rate, I need to subtract 1 from both sides. If I subtract 1 from both sides, that's going to be 1.0986 minus 1 must equal to 1 plus I minus 1. So the 1 cancel here. So 1.0986 minus 1 is going to be, so interest rate is going to be 0.0986, which is the same thing as 9.86%. So that's how you solve for interest rate. Very easy. Okay. So that is as far as a simple loan go. We just apply the simple formula. So now let's go to more complicated stuff. Let's talk about the second financial instrument, a fixed payment loan. A fixed payment loan is different from a what? From a simple loan. Okay. So the formula for a fixed payment loan is given by this. So first of all, fixed payment loan is also called in finance, we also, from the concept of amortization, it's also called fully amortized loan. Okay? Another name for this, fully amortized loan. A fixed payment loan is where when you pick up that loan, you're going to pay the fixed amount to the bank until maturity. For example, if you buy a house, you get a mortgage loans. You're going to be paying fixed mortgage to your bank until maybe for 30 years. Monthly payment, those are 360 months, by the way. If it's a 20-year mortgage, those are 240 payments because you're making monthly payments. Okay? So I want you guys to analyze that, that's what a fixed payment loan is. Student loan, once you finish your college, you're going to start making monthly payment on your student loan until when you fully pay off your loan. And then one thing that is true for a fixed payment loan is that for a fixed payment loan, there is no future value. There is no future value. Once the loan is fully paid in full, the future value goes to zero. Okay, that's why you don't see future value in this formula. So this FP here that you're seeing here, that stands for fixed payment. It's right here. And people who have used financial calculator, if you're using the financial calculator, this fixed payment in your financial calculator is the PMT function in your financial calculator, is marked PMT, fixed monthly payment or fixed period payment. So the formula seems very complicated. Think about it. If this is a 30-year mortgage and you're making monthly payment, 30 years, how many months are in 30 years? 360 months, because you're multiplying 30 by 12 months. So if you're calculating the present loan value is the same thing as present value. So the present value or loan value of a fixed payment loan, you'll be adding block by block. You know, I put dot here, but that's gonna go and it's gonna go up to 360. You're not gonna be able to do that by hand. You're gonna make mistakes. You're gonna get burned out. Takes you forever. So what I'm gonna do, as I told you in the beginning, I want you to know how to use algebra to figure out the formula, how to calculate this loan value or present value on a fixed payment loan without using a financial calculator. That's the goal here. And the guys who already know, people who know how to use a financial calculator, you're going to appreciate this. That, oh, I've been using a lot of black box. Because a financial calculator, anybody can be, even a 5-year-old can be taught now to use a financial calculator. It's like using a remote control for your TV at home. You can teach a 5-year-old how to flip on the channels on your television at home. How is that different from a financial calculator? Whereas, you know, they say, okay, we as a present value, give us future value. It's too much of a black box. So we need to understand the formulas that got programmed underneath that financial calculator that makes the calculator do what it is doing. That's the main goal. So the first thing I'm going to do, I'm going to reduce this formula to a level that can be, then we can apply geometric progression series idea. So it's going to be fun. So you just bear with me. So let me open a new slide here and we'll talk about it on the other side. Okay. So here we know that the loan value or the present value of a fixed payment loan, I use a different pen, this color pen here looks better. The present value, or what we are calling the loan value, is given as fixed payment over 1 plus I plus fixed payment over 1 plus I squared plus fixed payment over 1 plus I to the power 3 plus this is going to go up to fixed payment divided by 1 plus I to the power n. Okay? And by the way, there's something that is unique about fixed payment loan. Fixed payment, once you pick a loan from a bank, like a mortgage or a car loan, your first payment is not immediate. If you buy a car, let's say you went to the dealership and pick up a brand new Camry on, let's say, June 10th, or even June 1st. Once you sign off on that car payment, on that car, you buy that car and you finance it, your bank loan, your car note is not due until July 1. It's 1 month after your purchase the car. That's the reason why for a fixed payment loan, this is when I say 1 plus I here, that means n is what? We're raising this to the power 1. That means your first payment, because it has to be discounted. The present value is a discounted future value of something. We're discounting all future payments on that loan. Okay? So the present value of a fixed payment loan is the sum of all discounted future payments, fixed future payments. The first payment, of course, begins after one period after you pick up the loan and continue like that. So what I'm gonna do here is that what I'm gonna do here, I'm going to convert this. I'm gonna say, remember, first of all, I is a number that lies between 0 and 1. Okay, interest rate is bounded between 0 and 1. If you pick up a loan, your interest rate is always like 5% or 10%. 10% is 0.1. 0.1 is a number that lies between 0 and 1. You'll never pick up a loan and the bank says your interest rate is 200%. If it's 200%, that means interest rate is 2 in decimal. That will never happen. Interest rates always lie between 0 and 1. So even if you're interested, you get the highest interest rate in the country where you're paying 30% on a loan. 30% is still a number that is less than 1. It's 0.3. So we're going to assume that we're going to make this formula simple. We're going to say let R. Now you can pick any letter of the alphabet, but I like to use R. Let R equals to 1 over 1 plus I. Okay, so now I want you to get this right. If you say interest rate I lies between 0 and 1, you pick any number which lies between 0 and 1, like 1/2, like 1/3, 1 over 7, 1 over 9. As long as that number is a proper fraction that lies between 0 and 1, if you divide, if that means if you take 1 over 1 plus that interest rate that lies between 0 and 1, that means the R here is also gonna be a number that lies between 0 and 1. That's true. You can try during your free time. If you substitute 1/2 here, for example, if I is 1/2, 1 divided by 1 plus 1/2, that's gonna be kind of like 2/3. It's still a number that lies between 0 and 1. Okay, but if I say let R equals to 1 plus I, so first of all, I'm gonna rewrite this. I'm gonna say the present value can be written as fixed payment times 1 over 1 plus I plus fixed payment. You can rewrite this like this. That means the same thing. 1 plus I squared plus fixed payment times 1 over 1 plus I to the power 3. And then this goes plus dot, 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 plus fixed payment times 1 over 1 plus I raised to the power n. Now, since I said R equals to 1 over 1 plus I, that means the present value, the loan value, is just going to be fixed payment multiplied by this 1 over 1 plus I is R, plus fixed payment. This is going to become times R squared, because R is 1 over 1 plus I, so 1 over 1 plus I squared is R squared, plus fixed payment, even 1 over times 1 over 1 plus I to the power 3. Okay, that's going to be times R to the power what? 3. You can add another term because I put dot dot too soon. You could also say fixed payment. The number that follows 3 is R to the power 4. So it's going to be times R to the power 4, and then plus dot 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 plus FP times this is going to be R to the power n. So, but you see, FP, fixed payment, is common everywhere. We can factor that out. So if you factor out our FP, let me go back. Let me go here and open a new slide. I want you guys to follow this because I'm developing for you a formula that you can use a scientific calculator and get the same answer that finance people get with a financial calculator. Okay, that's what we're doing. What the finance people are getting with a financial calculator, we're gonna get the same thing. So now, let's play here. So we're saying now we know. I'm gonna duplicate this first. It's jumped. There. Okay. So we just say the present value or the loan value of a fixed payment loan. We say it is FP times R plus FP from the previous slide times R squared plus FP times R to the power 3 plus FP times R to the power 4. We say that dot times FP times R to the power n. So now you see FP is common. So we're going to say present value is going to be equal. So we can factor FP outside. Inside, this is going to be R plus R squared plus r to the power 3 plus r to the power 4 plus this is going to go up to plus r to the power n. Okay, so I want you to think about what is in this parenthesis. Okay, this is we have two types of series that you guys learn in grade school. There's what we call a arithmetic series and a geometric progression series. So whatever you have in parentheses here, this r plus r squared, r cubed, r4 to the rn, this is what we call a geometric progression series. A geometric progression series. A geometric progression series is a series where any two consecutive members of the series, two consecutive members, just jumping, two consecutive members will have a common ratio. What do we mean by that? If I take the first two, these two consecutive members, and I get the ratio between them, the ratio means I'm dividing r squared by r. That's going to equal to r because, see, r squared divided by r is r because this r is going to cancel that square. And then if I take the second two consecutive members, which is r squared and r cubed, and get the ratio, so r cubed to the power r squared, you see, this is going to be r. We go to the second two consecutive members, r to the power 4 and r, so you see, so r to the power 4 divided by r to the power 3, that's going to be r. So there's a common ratio r between any two consecutive members. That is true for all members of the series. Then this series better be called a geometric progression series. Okay? So now let's keep digging. So now I want to set this aside. So you call for me, let's call this equation A. So I'm going to go to explore what how do we sum a geometric progression series? So there's a handout that I gave you, which accompanies this chapter. If you go at Canvas and the course module, there's a PDF, which is, say, handout 1. The title is handout 1, formula derivations. I'm gonna go through that handout right now to then eventually derive the formula, how we sum up a geometric progression series and combine it with this so that we get a formal formula for calculating the present value of a fixed payment loan. And that's a formula that got programmed underneath the financial calculator. That when you go to the dealership, finance people just say, oh, we can figure out the present value of fixed payment on your loan by pressing on a financial calculator. But since we are going to be deriving the formula means we will have the knowledge of using mathematics and regular scientific calculator to come up with the same answer that the financial calculator is giving us. That's the goal. Okay. Keep this. So let me create a new slide here. So I'm going to go through that handout because the handout is a PDF. I cannot write on a PDF with this digital pen. It's extremely difficult. So let me open a couple of new slides here so that I don't have to be going through the process, because it's going to be a couple of steps that I'm going to be using to derive this formula. I need a few empty slides. One more. Okay. First of all, I just want to share with you. I'm going to share with you that what that handout looked like at Canvas. So if I hit share here, where do I have it here? No, here. I need to go back to Canvas. Just hold on a second. Okay. But that handout is there. I want to go through it. Go to modules. There is a handout 1 formula derivation. Okay, so I want to share this. I see how it looks like. That's how that handout looks like. Okay, so we want to try to see how we can sum a geometric progression series. So I want to go through this stuff. It's very easy. And I'm never going to ask you a question on this in this class to learn how to derive. But as long as you can remember or even learn how to master how to derive it, you understand at a much deeper level. It's not my goal to come to this class and write formulas on the board for you guys to just memorize it to pass the time. I want every formula that I write on the board in this class, I try to show you where it comes from because I want you to understand it so that if you forget one day what that formula is, you can derive it yourself. That's a goal. So let's go back and go back to my empty slides that I created and derive and go through that formula. Okay, so it's a little bit kind of blocking me. Okay. Okay. So now, so this is a formula about deriving time value of money formulas. That's handout 1 that I showed you. So we're going to say, suppose there's a series, the sum, Sn stands for the sum of a series which has an end date. N is like that. So that means this is a what? This N stands for the sum of a finite series. Finite means there's an end date. N could be 30, could be 40, could be 20. Like for mortgages, you cannot go beyond 30 mortgages. People pick 30-year mortgage, 20-year mortgage, 15-year mortgage, 10-year mortgage. So we're saying if we sum, we're going to sum some series that has got an end date. I'm going to write the summation sign here. This means I'm summing some series whose values start from k equals to 0 to n. In bracket here, or inside the parenthesis summation sign, I'm going to put r to the power what? To the power k. So if I distribute my numbers, k start from 0. So if I put k equals to 0 here, that would be r to the power 0. Any number to the power 0 is 1. You know that in mathematics, anything raised to the power 0 is 1. So if k is 0, put 0 here. That's going to be r to the power 0. So the first member of this series is going to be 1. Plus, because I'm summing, that means I should add. So the second member of the series when k equals to 1. You put 1 there, r to the power 1, that's going to be r. Then plus, the next member of the series when k equals to 2. So k equals to 2, put 2 there, that's going to be r squared. Plus, if k is 3, you put 3 there, you're going to get r to the power 3. And then here you can see the pattern, r to the power 4. This is going to continue. I put dot here up to r to the power n. Because the last term is n. When I put n here, that's the last term. So I'm going to name this equation 1. And then what I'm going to do some mathematical analysis. I'm going to say, an equation, what you do on the left, you must do on the right. So I'm going to say multiplying both sides by r. What do I get? If I multiply both sides by r, that means the left-hand side is going to be r times Sn. And then the right-hand side is going to be r inside 1 plus r squared plus r to the power 3 plus r to the power 4 plus this is going to go up to r to the power n. Of course, no, now that means r times Sn is going to be equal. So if I distribute this R inside the bracket, R times 1 is R, plus R times R is R squared. R times R squared, that's R to the power 3. You know that. R times R to the power 3, that's going to be R to the power 4. R times R to the power 4, that's going to be R to the power 5. Plus dot, 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 up to, okay. R times R to the n is what? You guys know the rules of exponent. If you're multiplying R, because R by itself is raised to the power 1. And I'm multiplying it by R to the n. If you have the same base, you add the what? You add the exponent. So this is the same thing as R to the power n plus 1. So if I multiply R, because this R is inherently is a 1 is raised to the power 1 times R to the n, the last term is going to be R to the power n plus 1. So I'm going to name this equation 2. And then what I'm going to do, I'm going to say subtract equation 2 from 1. 1 minus 2 means this is equation 1. I'm subtracting equation 2 from equation 1. What do we mean by subtract? If you have an equation, let's say side note here, if you have something like x equals to y, and as one equation, and another equation equals to maybe z equals to p, and I say subtract this equation from this equation, that means you subtract left-hand side, it would be x minus z must equal to y minus p. That's how I mean by subtracting one equation. So when I say subtract equation 2 from equation 1, it means I'm going to subtract the left-hand side and subtract right-hand side. So left-hand side of equation 1 is Sn. I'm going to subtract from it Rsn, which is the left-hand side of equation 2. Then that must be equals to the right-hand side of equation 1 is 1 plus R squared plus R to the power 3 plus R to the power 4 plus up to R to the power n. I'm subtracting from it the right-hand side of equation 2, which is giving us R plus R squared plus R to the power 3 plus R to the power 4 plus R to the power 5 plus this is going to be up to. Now I want you to be smart here. If R to the power n plus 1 is the last term, which term immediately precedes R to the n plus 1? Of course, it's going to be R to the power n before you hit what? R to the n plus 1. That's right. So if I do that, and you can add more terms here because this is R to the power 5. So, you can add. So all these terms are going to cancel out. All these terms are going to cancel out up to R to the n. The only terms that survive, okay, so it's going to be, the only term that survives. So on the left-hand side, we still have Sn minus Rsn. We only one is surviving on the right-hand side minus the last term here because it's a minus sign here. The last term is what? Is this term here, R to the n plus 1. Those are the only two terms that survive on the right-hand side. Okay? So now we have found that Sn minus Rsn equals to 1 minus R to the power n plus 1. So Sn is common on the left-hand side. I can factor that out. So this can be Sn inside 1 minus R. Yeah, that's the same thing. Because if you distribute Sn times 1, you get Sn. Sn times Rsn, you get what? Rsn. So that's going to be the same thing as 1 minus R to the n plus 1 on the right. Then I'm going to divide both sides by 1 minus R. Divide both sides by 1 minus R. So the 1 minus R here cancel. So that means the sum of any finite geometric progression series, finite means the series has got an end date. You just take 1 minus R to the n plus 1 over 1 minus R. As long as what? As long as R lies between 0 and what? 1. R must be a number that is bounded between 0 and 1. That's what we said in the beginning. Okay? Now, we can play a little bit now with this stuff. But remember, okay, I'll come back to that. This is for finite series. What about infinite series? What about infinite series? Series that don't have end date, even though we may not use this immediately, but it's good to think about that kind of in abstract sense. When I say infinite series, that basically means n tends towards infinity. N gets large. Now think about it. Remember, n is a number that is a fraction, it's a proper fraction, lies between 0 and 1. I mean, this n here lies between 0 and 1. So not n, I'm sorry, r. R is a number that lies between 0 and 1. So if you, let's say, if you assume r is good, some a number like 1/2. Okay? If I raise r this to the power 1, that is 1/2. If I raise that r, which is 1/2 to the power 2, you get a much smaller number. If I raise 1/2 to the power 3, that is 1 over what? 1/8. So as you raise r, which is a fraction, to higher powers, the numbers you get smaller and smaller. So that means as n tends to infinity, and you raise 1/2 to the power infinity, that is going to go to 0. So that means, okay, so what we're saying here is that we're saying that Sn, as n goes to infinity, is going to be the same thing as 1 over 1 minus r. Because as n goes to infinity and r is a fraction, r to the power n plus 1 is going to go to 0. That's right. So this would be the formula for an infinite series that don't have an end date. We'll come back to that later. We're going to do something about a specific type of coupon bond. But our main result that we want to use is this guy here. Okay, now let's go back. So remember, I already said that, let's pull the formula for the loan value. Fixed pay, we say that the present value, okay, goodness. We say that the loan value or the present value of a fixed payment loan, we summarize that. We said it was fixed payment inside r plus r squared plus r to the power 3 plus r to the power 4 plus this went up to r to the power n. Remember, we did that. We called that equation A earlier on. Now, I want you to compare that, compare what is in the bracket here with the formula that we just calculated from. We say that the sum, if you're summing a geometric progression series, which is we should just talk about it, k equals to 0 to n, r to the power k, which is the same as 1 plus r squared plus r to the power 3 plus r to the power 4 plus r to the n. We say that this series sums to what? This thing is going to sum to 1 minus r to the n plus 1 after we did our manipulation, right? The mathematical, derivation. It came to that. So the sum of this series, which is this guy, sums to that. That's how you get it. Now, but I want you to compare this series here with this series. This one here starts from 1. This starts from r. And because this is a fixed payment loan. When you take a loan from a bank, I say that your first payment is not immediate. It starts 1 period after you pick the loan. Okay, that's why we're starting at r here. It's not starting at 1. So we are losing 1. We're just losing 1 from this formula. So that means we can recover that 1. We now can write the formula for the fixed payment loan in this way. We can say the loan value or the present value of a fixed payment loan. You take fixed payment, so it's going to be the same. This formula here, 1 minus r to the n plus 1 divided by 1 minus r. But then we have to recover the 1 because we're missing a 1 here. So we subtract that 1 from that formula. This is the formula that has been programmed underneath the financial calculator that allows you to do whatever you want to do with that calculator. Okay. Let me open a new slide. We're going to be doing some example here shortly. Let me first get a new slide. It looks like I ran out of space here. Oh, I left some space on top. Okay. I'm gonna get a new slide here for sure. Okay. Why is it opening on top? It's kind of weird. Yes, you need to do that probably. Okay, that's better. We gotta go delete these ones. You know why they created them on top? Kind of weird. Delete this one. Cut. Okay, delete this one. Okay, so we have this at the bottom. Let's create one more. Okay, now it's working better now. Okay, one more. Okay, so we just I want to rewrite this formula again. So we just came up with a beautiful formula for that we're gonna be applying to calculate the what, the present value or the future value, whatever you want to calculate on a fixed payment loan. Okay, and the formula says what? I use blue probably looks nice. Okay, so it says that the loan value or the present value of a fixed payment loan, we now found that it can be written as fixed payment inside 1 minus r to the n plus 1 divided by 1 minus r, then minus 1. Keep in mind that this 1 we are subtracting is not part of this ratio. So you must first divide 1 minus r to the n plus 1 divided by 1 minus r, then subtract 1 from it. Or in a more condensed form, since what? Since r is 1 over 1 plus I, because that's what we said at the beginning. Or you can write this loan value or present value is going to be equals to, you can introduce a big bracket here, say fixed payment inside 1 minus, r is going to be 1 over 1 plus I raised to the power n plus 1 divided by 1 minus 1 over 1 plus I. See that? Then minus 1. You can also write it like that. Okay? So this is the formula that got programmed underneath that financial calculator. Now, let's go and do an example. Okay? Let's go and do an example that will solidify your understanding of this topic. And that example is on page 2. I believe it's on page 2 of that handout that I told you. So let me share my screen on that handout again. Then we talk about it. So I want you to see the question, but remember I can't write on that PDF file. I need to go back. So I want us to do an example, which is at the what? The middle of page 2 of the handout. So we said we are going to use both math and regular scientific calculator. And then we also use the financial calculator. The answer we get is going to be identical. So you say, now try. So you decide to purchase a new home and you need $100,000 mortgage. That's what the question says. So you take out a loan from the bank that has got an interest rate of 7% per year. What is the yearly payment to the bank to pay off the loan in 20 years? So N is 20. It's a 20-year mortgage. So I already know everything. I recorded what I read here. So I'm going to go back to our slide and summarize what we have seen in that there. Okay. So the question is that you have what? You want to buy a brand new home, you need $100,000 mortgage. So that's the loan value. Loan value is the same thing as present value, remember. Is $100,000. Summarize this. Okay. And then the loan has to be paid back in full amount of 20 years. So N is 20. The interest rate on this loan is 7%. 7% is the same thing as 0.07 in decimal. Okay. So for the and then we are supposed to calculate the fixed annual payment every year. Again, okay, fixed payment in years. Annual. How much do you pay back to the bank every year? Okay. So we need to figure out this. For a fixed payment loan, I told you already, future value always goes to zero. Once the loan is fully paid off, there's nothing left. So if you're using your financial calculator, guess what? I have a couple here. I have a BA22, then I have another model here, which is a TI-83 plus. All of them work a little bit differently. Okay. So if you're using a BA2 plus calculator, it's very easy to use. So now I'm gonna say in a world with financial calculator, what would you do here? So in a world with financial calculators, it's very easy. You're going to input these values. Okay, so there's we have the present value here. That's 1 over I, that's the interest rate. So, but if you're using it, anytime you enter that value, you must enter it. So you're gonna say, for example, I'm gonna say N is 20. So I put 20, then N. See? So something I know you can't see my calculator, but then I need to enter that value. So I'm gonna say enter. Then if you don't enter it, it doesn't record it. And then I'm gonna do future value is 0. So F is gonna say 0, and then future value, because for the fixed payment loan, you have to enter 0 as a future value. Then enter. Where's my entry? There you go. So it sets the value, it records the value underneath it. If you don't enter it, it's not going. Press enter after entering the number and putting, and then we're gonna do interest rate, which is 7%. So 7 I, then enter. Okay, and then the loan value is a present value. Okay, so this is a tricky part. Remember, when you take out a loan is like you owe somebody money. So when you're using financial calculator, this is like negative because you owe the bank money. So then you're gonna enter minus 100,000. Okay, let me write this. 100,000 minus, okay, and then the present value, that's a loan value, PV, okay, then enter. And then I'm gonna compute. So now the only thing that is remaining that which I'm supposed to solve for is the future value. There's a FV there. So how do I do it? So there is a notation there for compute. Okay, so I'm just gonna say compute future value. Okay, so once I hit compute future value, it gives me, so I find FV equals to $9,439.29. Let me see a little bit here. There's something that I need to. Each calculator is different though. So you say 100,000. Okay, that's present value. Enter without a negative. Let's say 100,000. 100,000. Present value. Then enter. Then we're gonna do N is 20, so 20. Then you do N. Enter. Then we're gonna do interest rate, which is 7. Then enter. And then future value is 0. Okay, there you go. I think I calculated something else. I made a mistake. Yeah, that earlier one. Okay, enter. So I did enter, and then compute payment. There you go. It's 9,439.29. Okay, that's what you got. That is using financial calculator. It's easy piece. So this is how much you're going to be paying to the bank every year. So suppose I ask you to calculate the monthly payment. If it was monthly payment, you cannot divide this by 12 because interest rates are different. When we say annual interest rate, is different from monthly interest rate. So, and your textbook does a very good job, but I'm not going to be testing you on that. Goes a great deal of explaining how you convert annual interest rate to monthly interest rate. I'm still recording lecture. I'll call you back. Hello? Yeah, that's fine. Yeah. All right. So you cannot just divide this number by 12. If it was monthly. You need to first know how to convert monthly payment, annual interest rate into monthly interest rate. But this is going to be the annual mortgage payment due to the bank every year. Okay, $9,439. Okay, now that is that. What about in a world without financial calculator? We can still survive. Okay, so we're gonna say in a world without financial calculators. And the finance students who are used to using financial calculator, you're going to appreciate this because now you will have two ways of calculating fixed payment or present value on a loan. You can know how to use a financial calculator. What if you don't have the financial calculator? You can use math that I just derived, the formula, with a regular scientific calculator. So what does our math say? It says, we just derived the formula. It says the loan value or the present value of a fixed payment loan is given as you take fixed payment inside 1 minus r to the power n plus 1 divided by 1 minus r minus 1. That's the formula. But remember, your r is 1 over 1 plus the interest rate. Now here, you're not going to round anything. Whether you have to use 9 decimal points, you need to, because if you round it, you're not going to get the same exact answer that the financial people are getting. Don't round too soon. So the first thing you're going to do, you're going to get that R. We know I is what? 7%. 7% is 0.07. That is given here. So R, you're going to say R equals to 1 over 1 plus 0.07. Oops. Okay. So that means R is going to be equals to 1 over 1.07. Please don't round this number. You're just going to get all the digits. They're going to be, might be ugly, but you record it down somewhere. So 1 divided by 1.07, what do I get? This ugly number is 0.934579. I hate this. What is this? Okay. 4574579. Okay. 9 decimal places. Keep all that. If you round it like to 0.93 or 0.9, your answer is not going to be the same. Because the formula was programmed underneath the financial calculator without rounding. They programmed the whole formula, meaning that there's no rounding. You round it, your answer is going to be incorrect. Now let's get to work. So our goal, we want to find the fixed payment. So we're going to substitute in the known values. Okay, so let me open another slide here to we complete this. Okay. So now I want to duplicate that. What did we find? This is your interest rate. I want to summarize that. So we found a little r equals to 0.9. I want to be exact, 345 4, 5, 7, I believe. 9439. 9439. So what's the formula say? It says loan value, the formula we derive, or present value, is given as fixed payment inside 1 minus r to the n plus 1 over 1 minus r minus 1. So our loan value is $100,000. So here you're not going to use negative number. It's a positive number. This is a formula. Fixed payment is what we are solving for. Inside is going to be 1 minus 0, that ugly number, 0.9345799439. This raised to the, remember n is what? N is 20. But this is 20 plus 1. So that's going to be to the power 21. Don't get confused there, because n by itself was 20. But you know the formula says 1 minus r to the n plus 1. So that's going to be to the power 21. Divided by 1 minus, again, that ugly number, 0.9345799439. Then we're going to subtract 1 from it. That's it. It's awesome. So what you want, what you're going to, and here now you can use just a regular scientific calculator. So I'm going to use just regular scientific calculator. I'm going to program this part on my calculator. I'm going to say whatever is in bracket is 1 minus, and then I'm going to introduce a bracket. You write 1 minus, because it's a big number raised to the power 21. You write 1 minus, then open bracket, then enter that ugly number, which is 0.934579439. Then close the bracket, then raise, there's a power button here, raise it to the power 21. And then I'm going to say enter. Okay, and then I'm going to, so that's that part. Then divide by, then I'm going to introduce bracket again. 1 minus 0.934579439. Close bracket, enter. Then I'm going to, so I get 11.5. Then subtract 1. 1 is not part of the ratio. Then I have to subtract minus 1. You guess what I get? So that basically means, it's going to mean $100,000 is going to be equal to your fixed payment. So whatever I found in bracket here is 10.59401,422. Okay. Now to solve for FP, you're going to divide both sides by that ugly number, 10.59401,422. Divide both sides by 10.59401,422. So these cancel. So in your calculator, you still have that 10.59. So if you're using the calculator, you've already programmed that. You don't need to go to this step, because since we're dividing by this, because the 10.59 becomes inverse because you're dividing both sides. There's a function in the calculator here which is written x to the power -1. X to the power -1, that means you are getting 1 over 10. So you are just going to press the inverse of that answer and then multiply that inverse by $100,000. What do I get? Get the same answer. So you get fixed payment. Fixed payment equals to $9,439.29. That's exactly what the finance people got with their financial calculator. That is how you calculate your payment on a loan. Okay? We're going to meet tomorrow. I may go through a little bit on this again one more time. Just when we meet tomorrow, like live screen tomorrow. So that, because I want you guys to understand this very well. And you can think of different examples. Think about, what about if the N was 30 and interest rate was 8%? Practice using different examples. Learn how to calculate your payment on your loan. Because at the end of the day, after taking this course, there's going to come a time when you're going to buy your own house. And you don't want any finance expert to cheat you out there because they figure out that you didn't know how to calculate your payment on a loan. Or they might make a mistake and you start paying, even if you're paying $500 more every month. That's a lot of money you're losing. So this is like life right here, like, because you're going to be buying houses, you're going to be buying cars in the future. Okay, so you got to know how to what? Anytime you buy things of value, you finance, the concept of interest rate comes to value, time value, money, present value, future value. So you got to know how to calculate the payment on a loan. That's exactly what we did. So I've shown you how to calculate the payment on a loan using both the formula method and the what? The financial calculator. Okay. So the next thing that we're gonna do, we're gonna talk about that's fixed payment loan. So then the third credit market instrument that we need to talk about is what we call a coupon bond. Okay. So I want to first summarize the characteristic of a coupon bond, because I want you to understand it very well, that when you go start trading next time, when you get your nice job and you start making money, you want to buy bonds, you understand what a coupon bond is. And then we also going to talk about discount bond. So let's talk about a coupon bond. So a coupon bond pays fixed coupon, C, big C, which is in dollars, every period. Period could be year. Every period until maturity. That's one thing. So how do we determine, first of all, how do we determine this coupon? So for example, if you buy a $10,000 coupon bond from, say, US government or from some corporation, and that bond is maturing in 10 years. The government might say every year we're going to send you a check, a fixed coupon payment of $1,000 until maturity. So your $10,000 is going to be, they pay you back. But then on maturity, not only do you get the last coupon payment, you also get the face value of the bond back. Okay? And I'm going to talk about what the face value of a bond means. The face value of the bond is not necessarily the price of the bond. They're different. Okay? Because bonds can be sold to you at a premium or at a discount. The price sometimes could be above the face value or the par value of the bond. So, but the first question is, how do we determine this coupon payment? So here's a formula. So the coupon payment C, which is in dollar paid for you, this is capital C, is going to be equal to lower C. I'm going to divide what that lower C means times the face value. So F here is going to stand for face value of the bond. The face value of the bond is also called par value. When you hear finance people talking about par value, the same thing as face value. And then this little c is what we call the coupon rate. This coupon rate is not the interest rate. We'll talk about again that. Okay, it's what we use for determining how much coupon payments you're going to get from a bond. And then, of course, this is your what? Your fixed period coupon in dollars. This little c, when you say coupon rate, this is in percentage. So it's 10%, 20% coupon rate. Let me do one example just on that to see how you determine that. Let me just give you a simple example here. Okay, so we're saying that the coupon on a bond is given as you take the coupon rate times the face value. So we can say, example, suppose a coupon bond, so I say suppose a 10% coupon bond has a face value of $1,000. And I say, what is the coupon payment? Very easy. So you just use the formula. Solution, face value F is what? $1,000. Little c, because it says 10% coupon bond, that means coupon rate is 10%. 10% in decimal is 0.1. Then just apply this formula. So the coupon payment on this bond is going to be little c times the face value, which is just going to be 0.1 times $1,000. So that means every period, you're going to be receiving a fixed amount of check equals to $100 until maturity. So if sometimes I may give you C, I might say the coupon payment on a bond is was 100 and the face value is 1,000. What is the coupon rate? So you just substitute the known value and calculate what? If I gave you this, the rate is $100 and I gave you this is $1,000. That means C is going to be 0.1 or 10%. Because you're going to be $100 on the left would be equal to little c times $1,000 on the right. Then divide both sides by $1,000. $1,000. Dollar sign cancel. So 100 divided by 1,000 is 0.1. So that would be the coupon rate. 0.1 is what? Is 10%. Okay. So that's one calculation. So that's how we figure out the coupon rate. Then the second character. So let's talk about more characteristics of a coupon bond. More features of a coupon bond that you need to understand. So first of all, we know that a coupon bond pays you fixed amount of coupon every period. We already talked about that. Okay. So the second relationship, the second feature of a coupon bond, what is this? Is that the price, the present value of a bond is the same thing as a price. The present value or the price of a bond. The price of a bond is a bond's present value. Right? I want to make that clear. So sometimes when I write on the test, the present value of a bond, that's the same thing as the price of the bond. When I say price is the same thing as present value. So I say the present value or the price of a coupon bond may be equal, greater, or less than the bond's face value. So here the relationship. So A, if the price of a coupon bond P or present value of a coupon bond equals to the bond's face value, we say that the bond is what? The bond is priced at par, at its par value. And that means it implies that the interest rate on this bond will equal to the what? The bond's coupon rate. Anytime the price of a bond equals to the bond's face value, the interest rate on that bond or the yield to maturity equals to the bond's coupon rate. B, if the price of the bond were greater than the bond's face value, okay? The price of the, so that's basically means that the bond is sold at a premium. Premium means the bond is priced above par. The price of the bond exceeds its face value. It means it's sold at a premium. So then that means the interest rate on this bond is going to be less than the what? the bond's coupon rate. That relationship is always true. Anytime the yield on the bond is less than the bond's coupon rate, that means the bond is priced above par, is par value. Then the last relationship, the last whatever there, when the bond is price is below its face value, we're saying that the bond is sold at a discount. Bond is going to be sold at a discount, or is priced below par. Then that means the interest rate on this bond has to be greater than the bond's coupon rate. This relationship will always be true. So if I gave you a question on the test, for example, and say, oh, the interest rate on the bond is 8%, and the coupon rate is also 8%. Calculate the price of the bond if the face value of this bond is $1,000. Don't even waste your time, because once interest rate equals the coupon rate, if I gave you the face value is $1,000 and I ask you to calculate the price or the present value of the bond, of this coupon bond, that means that price is going to be equal to $1,000. If I gave you an example on a test, you can check yourself. If the interest rate was less than the coupon rate, let's say the interest rate is 8% and the coupon rate is 10%. So the interest rate or the yield is less than the coupon rate. The price you are calculating must always be above the bond face value. If I give you a face value of $1,000, that bond price must be above $1,000. If it's not above $1,000, that means you're wrong. And then if the bond interest rate or the yield is greater than the coupon rate, like I say the interest rate is 12%, but the coupon rate is 10%, then the price that you are calculating for that coupon bond must always be less than its face value. Those relationships are true. Okay. Then the third relationship that I want to talk about when it comes to coupon bond, which is also very important, the third characteristic, make sure you're paying attention here. Before we write the formula, we'll make sure you understand everything about coupon bond. The third is that that on maturity, not only do coupon bond holders get paid the last coupon payment, but they also get paid the face value back, face value of the bond. So let's say you bought a $10,000 coupon bond, and the government say that matures in 10 years. That means every year, let's say the coupon payment is $1,000. You're going to be collecting $1,000, $1,000, $1,000 for 10 years. If that bond has got a 10%, a $1,000 coupon, whatever sort of face value, or $2,000 face value, $5,000 face value, not only are you going to be collecting the last coupon payment of $1,000, but you will also get the face value of $5,000 on year 10. Okay, that's true for coupon bonds. So now we can write the formula for coupon bond. Now let's do it here. So if P is the price of a coupon bond, which is a price, is also the same thing as present value of a bond, and C is a yearly coupon payment that we talked about, and F is the face value, N is the number of years. Then the present value, so you can read this is the price of a bond, remember, is the same thing as present value. The present value, the price of this bond is going to be calculated by summing all future discounted coupon payments. See, because when you buy a bond today, coupon bond today, let's say in 2025, after 1 year, you're going to receive maybe a $1,000 coupon payment. Let's say it's a 10-year bond. If your coupon payment is $1,000, you're going to be receiving $1,000 for 10 years. If N is 10, you would have received $1,000 for 10 years. And then on maturity, during the last year, not only do you get this last coupon payment, but you're also going to get the face value back. So the present value, we are summing all discounted future payments on that bond, which include all coupon payments plus the face value that you get paid back on maturity of the bond. That's right. So now it becomes very easy for us. So it turns out that the formula for a coupon bond is very similar to the formula for a fixed payment loan. Remember the fixed payment loan, the loan value, you already know this. I want you to compare these two formulas. You take fixed payment over 1 plus I plus fixed payment over 1 plus I squared plus fixed payment over 1 plus I to the power 3. And this goes up to fixed payment over 1 plus I to the power n. A fixed payment loan, there's no future value. Okay? By the way, the word face value for the bond is the same thing as future value. Okay? So for a this is a fixed payment. We talked about this already. So I want you to compare this formula with the formula which we just written for a coupon bond. Compare it with the present value or the price of a coupon bond. Okay? You sum up all future payments, coupon payment, which is C over 1 plus I, plus C over 1 plus I squared, plus C over 1 plus I to the power 3, plus this go up to C over 1 plus I to the power n. And then for the coupon bond, not only do you get the last coupon payment, you also get paid the what? The face value back on maturity of your bond to the power n. So when you compare this formula, this first part of this formula here that ends here, it's identical to this guy. Because C is the same thing as fixed payment. Even though this is a loan, if you take a loan, you're going to be paying the bank. If you buy a coupon bond, you're going to get paid because a bond is an investment. But the logic is the same. You're going to be paid fixed coupon payment. The person who issued you that bond, whether it's corporation, whether it's government, is going to be sending you a fixed coupon payment every year until maturity. That's the same thing as when taking a loan. You're gonna be paying the bank a fixed payment every year until maturity. The only difference is that for a coupon bond, not only do you receive the last coupon payment, but you also get the face value back. So now when we think about this formula in a more critical, so then we can go and do the same algebra manipulation that we did, the formula that I derived for you. So we can say then, if we have C, present value or the price of a coupon bond equals to C over 1 plus I plus C over 1 plus I squared plus C over 1 plus I to the power 3 plus goes up to dot C 1 plus I to the power n, then plus the face value over 1 plus I to the power n. We can rewrite this form. We can say let, just we did, we can say let R be equals to 1 over 1 plus I. That like we did for the fixed payment loan. Remember when I derived that formula? So that means you can write this as P equals to C times R. Because C over times 1 is going to be C times 1 over 1 plus I. But 1 over 1 plus I we're representing as R. Maybe I skip a step. Let me write this as C times 1 over 1 plus I first. So you see what I'm doing. C over 1 plus I squared can be written as C times 1 over 1 plus I squared plus C over 1 plus, C times 1 over 1 plus I to the power 3 plus this is going to go up to C plus C times 1 over 1 plus I to the power n plus the last term, which is going to be F times 1 over 1 plus R to the power n. Okay, and since 1 over 1 plus I is R, then we can say the price or the present value of a coupon bond is going to be C R plus C R squared. This one C times 1 over 1 plus I squared is C R squared. Plus this C times 1 over 1 plus I to the power 3 is going to be written as C R to the power 3. Plus this is going to go up to C R to the power N. Plus this is F R to the power N. And from here, you see C is common everywhere. We can factor that out. So this P is going to be equals to, we factor out C inside R plus R squared plus R cubed. This is going to have to be R to the power N, then plus FR to the power N. So this is what we found for the whatever fixed payment loan. We already have this formula. Remember this formula, whatever is in parentheses, we derive the geometric progression series. We say it equals 1. This series sums to 1 minus R to the N plus 1, divided by 1 minus R then minus 1. So that means we can summarize that as well here. So for a coupon bond then, okay, so first of all, we're saying that P equals to C inside R plus R squared plus R cubed plus this goes out to dot dot R to the power N, then plus what? FR to the power N. And we already showed earlier that P equals to C, whatever is in bracket sums to 1 minus R to the power N plus 1. We did this already, the handout. Divide by 1 minus R, but then you have to subtract 1 from it. But we have to add the last term. This is, okay, so you got this. So this is a formula that got programmed underneath the financial calculator for the coupon bond. And we're going to be doing an example. Okay? If you compare this with the formula for fixed payment loan. Compare with, which we found to be, we said the present value or the loan value was equal to fixed payment inside 1 minus R to the N plus 1 over 1 minus R minus 1. The only difference is that for a coupon bond, there's this last term, because a coupon bond has got a face value, future value. Future value is the same thing as face value. But you see, this fixed payment here in the financial calculator, this C is the same thing. You treat it as what? The PMT function in a financial calculator. That's the same thing. Okay, so let's go and do an example for that one. How we calculate the present value of the price of a coupon bond. Okay, because an example is always going to clear up things nicely. We're going to use both the financial calculator and then a regular what? We compare our answer with a regular scientific calculator and the formula. Okay, so again, the example is on page 3 of the handout. So if I may share that screen again, and you see where the example for the coupon bond. So you scroll down, that's a formula for the coupon bond once we, so here's the example that we need to do. Try this using a scientific calculator instead of a financial calculator, but we're going to do both. It says find the price of a 10% coupon bond, which has got a face value of $1,000 and has got a 12.25% yield to maturity. So that's the interest rate, and 8 years to maturity. Okay, so I already know that the interest rate is 12.25. The face value is $1,000. The bond has got a price. It has got a 10. It's a 10%. Coupon rate is 10%. So I can go back to our empty slide where I'm doing the calculation and share with you there what we're doing. Okay, that's where we are. So the question says, so I'm going to summarize that question here. We have been told that find the price of a 10% coupon bond. When I say 10% coupon bond, it means a little c coupon rate is 10%, which is the same thing as 0.1. Okay? The bond we have been told as a face value is the same thing as future value of $1,000. It has got an interest rate of 12.25% on this bond investment. 4.25% in decimal is given as 0.1225 in decimal. And then the bond is maturing in 8 years. So N is 8. So we have been asked to calculate the price. Remember, the price of a coupon bond or of a bond is the same thing as present value. Very easy. So now the first thing we need to do here, we need to figure out what the payment is. The payment is a coupon payment. In the financial calculator, the payment is a PMT function. And so that our payment when it comes to coupon bond fixed payment is USC. And the formula is to show you how do I calculate the fixed coupon payment? You take the coupon rate, little c, and multiply that by the face value. So this bond has got a fixed coupon payment of C is 0.1, 10% is 0.1. Multiply that by $1,000. So this bond is going to be having a fixed payment of what? $100. This C is the same thing as PMT in your financial calculator. Now it's $100. So we have what? PMT equals to $100. Okay? So using a financial calculator, this is what you're just going to do. You're going to enter these values. And I like the BA2 plus calculator. It's very easy to use because those functions are there, like the present value, interest rate, and payment, future value. So I'm just going to enter the future value is the FB is $1,000. So you enter 1,000 and then press future value FB, then enter. You must enter it because if you don't enter, it's not going to record it. And then the interest rate is 12.25%. So I'm going to say interest rate 12.25 interest rate, then enter. Records it. And then N is 8. So 8, then N, enter. Okay? Then payment, PMT, that's what $100 is. $100, then hit PMT, then enter. And then what we are computing for, the only unknown is now PV, present value. So I'm going to press compute PV. See what I get? It gives you negative, but you know, the price of a bond is not going to be negative. You know, it has to be a positive number. So, you know, so if the present value PV here is 889.20. That's what it gives you. Using a financial calculator. Okay, now what about using the formula method? Let's go use the formula method. So that the finance students who have been used to using financial calculator can appreciate. So we know the formula method says that the price of a coupon bond, we found it to be C inside 1 minus R to the N plus 1 divided by 1 minus R minus 1 plus FR to the power N. So let's substitute the known values. The first thing we want to do, we want to find out what R is. Remember, R is given as 1 over 1 plus I. And please don't round. Because if you round, you're not going to get the same answer like the finance people are getting with a financial calculator. So R is going to be 1 over 1 plus 0.1225. 12.25 in decimal is 0.1225. So that means your R is going to be equals to 1 over 1.1225. So you're going to enter all that with all the decimal points. Don't round. So 1 divided by 1.1225, that is given as 0.890868585969. You gotta write all that ugly now. Okay? Then now you're gonna write. So now let's substitute the known value. The known value is gonna, so that means the present value is gonna be equal to you already found this. C is 100. That's a coupon payment. Inside 1 minus, so we're going to be 1 minus this ugly number. So you have to introduce bracket 0.8908685,969. Okay, but that is raised to the power n plus 1. Remember, n is 8. So 8 plus 1, that's going to be 9. Divide by 1 minus, you have to introduce bracket, the ugly number, which is 0.8908685,969. Okay, then you're going to subtract 1 from it and close that bracket, plus the face value is $1,000, it's given in a problem, times R to the power 8. So R again is this ugly number. I just ran out of room. So make sure R is this ugly number, 0.8, 1,000 times 0.8908685,969, close bracket raised to the power 8. Okay, so I can do this in one line of programming. But if you're doing it for the first time, you can first get this part, then add it to this part. But you can do it in one line. So using a regular scientific calculator, not a financial calculator, just regular scientific. It still has to be a scientific calculator. If you just have some calculator on your phone, that's not going to work. You need to, if you have to be a calculator with scientific function in it. So what I'm going to do, I'm going to program what is in parentheses first. So which is going to be 1 minus, then I introduce bracket, that's going to be 0.8908685,969, close bracket, raised to the power 9. So power button here, raised to the power 9, enter. And then I'm going to divide that by, introduce bracket, 1 minus, again, the ugly number, 0.8908685,969. Close, enter. And then I subtract 1 from it. 1 is not part of the ratio. Then minus 1. So whatever I get in that bracket, this junk here, it comes to 4.9245471. And then I'm going to multiply it by 100 because $100 is outside here. So times 100. Okay, gives me, so this first part here is 492 point, don't round, 4547464. Then plus, then you do this part. But I'm going to do it in one line of coding. So I did get that phone. Then I'm going to add to it. Then deal with this second part. The second part, I need to raise R to the power of it. But R is an ugly number. So that's going to be, you can write that as, you can say bracket 0.8908685,969. You're raising that to the power of 8. Okay. And then you're going to multiply that by $1,000. So so I get one answer. My answer is yes, sir. So whatever this part is, I just did it in one line. So I get the same answer that the finance people got with a financial calculator. It's 889.19, which is 0.20. So you get price equals to 889.1976, whatever, which is the same thing as, what we got with the financial calculator, 889.20. So that is how you can learn how to use, both financial calculator and the what? Calculator, for a regular scientific calculator, but with formula. So with that in mind, I'm going to conclude this. I don't want this particular lecture to be super long. We are going to be picking up from there tomorrow on full speed, so that you can get to do these things very easily. Okay, I'll see you guys tomorrow. Thank you. Bye.